Hello, I am Priyanka Chakraborty. In my previous video, I was discussing about the full wave rectifier, that is center tap full wave rectifier and bridge rectifier. Today, I'll discuss about the average current of full wave rectifier, DC, RMS current of full wave rectifier, ripple factor, and etc. So, first of all, what is average current of AC signal? When the AC voltage signal completely represents the DC voltage signal, then that value of DC signal is called average value of AC signal. Okay, so here we see the waveform for full wave rectification. So we can say that here V0 equal to Vm sin omega t when omega t in between 0 to pi, and minus Vm sin omega t when omega t in between pi to 2 pi. This is for the negative half cycle actually. And IL equal to Im sin omega t when omega t in between 0 to pi, and for negative half cycle we can say that IL equal to minus Im sin omega t when omega t in between pi to 2 pi. So this is the formula for average current calculation. I average or IDC equal to 1 by 2 pi integration of 0 to 2 pi IL d omega t. Actually, you have seen it in the half-wave rectification for the calculation of DC current or average current. So the formula is same actually. So now we put the value of IL in the equation. The value of IL for 0 to pi, that is Im sin omega t, and for pi to 2 pi that will equal to Im minus Im sin omega t. So now we just calculate it. Im is the constant term. So now we write Im by 2 pi. So if I integrate this, we get minus cos omega t 0 to pi and minus cos omega t pi to 2 pi. So if we calculate this, we get the value of IDC, that is equal to 2Im by pi. Okay, so this is the average current for full wave rectifier. It is for center tap full wave rectifier as well as bridge rectifier also. So now the calculation for RMS current. So what is RMS current? When the AC voltage signal supplies same amount of power as in DC, then the value of DC voltage is called root mean square or RMS value of AC. Okay, so this is the formula. In this case also the formula is same as half wave rectifier, that is IRMS square equal to 1 by 2 pi integration of 0 to 2 pi IL square d omega t. We just put the value here, the value of IL when it is in between, when the omega t in between 0 to pi, it is Im sin omega t, and when omega t in between pi to 2 pi, it is minus Im sin omega t. So it is Im sin omega t Im sin omega t whole square d omega t plus integration of pi to 2 pi Im sin omega t whole square d omega t. So Im is the constant term, Im square actually is the constant term. So we just put it out, Im square by 2 pi integration of 0 to pi sin square d omega t integration of pi to 2 pi sin square d omega t. I just put the value of sin square d omega t, that is 1 minus cos 2 omega t by 2. So just to the integration. So at last we get the value of IRMS, that is IRMS square, it is actually Im square by 2. So this is the value of IRMS, that is equal to Im by root 2. This is the value of IRMS square. So IRMS square equal to Im square by 2. So IRMS equal to Im by root 2. So this is the RMS value for full wave rectifier for center tap and bridge rectifier. So this is the ripple factor calculation. We know that the formula for ripple factor equal to root over of IRMS by IDC, the IRMS by IDC whole square minus 1. So we know the value of IRMS that is equal to Im by root 2, and we know the value of IDC, that is equal to 2Im by pi. We just put the value here, that is Im by root 2 by 2Im by pi whole square minus 1. So if we calculate this, we get the value 0.48. So the ripple factor for full wave rectifier, that is equal to 0.48. The formula is actually the same for half wave and full wave rectifier. Just we have to change the value of IRMS and IDC. So this is the calculation for rectification efficiency. Here also the formula is same. The rectification efficiency is denoted by eta, that is equal to PDC by PSC. So PDC equal to 4 by pi square Im square RL. We get the value in case of half wave rectifier. Please watch my video of half wave rectifier calculations. So we get this, and PAC equal to Im square RF plus RL plus RF plus RS plus RL, sorry, by 2. So we get, if we calculate this, we get the value of rectification efficiency, that is equal to 81.2% actually. Okay. So now the peak inverse voltage. So suppose Vp is the maximum voltage across the half of secondary winding. This figure shows that the circuit at the instant secondary voltage reaches its maximum value in the positive direction. At this instant, diode D1 is conducting while diode D2 is non-conducting. Therefore, whole of the secondary voltage appears across the non-conducting diode. Consequently, the peak inverse voltage is twice the maximum voltage across the half of secondary winding. That is PIV equal to 2 into Vp. So this is actually you can see this is the circuit for center tap full wave rectifier. So this is the peak inverse voltage for center tap full wave rectifier. But for bridge rectifier, the peak inverse voltage will be Vp, only the maximum voltage. Because for center tap full wave rectifier, we use the center tap transformer. But in case of bridge rectifier, we just use the normal transformer. That's why the peak inverse voltage for center tap full wave rectifier, that is equal to 2 into Vp, where Vp is the amplitude of the input signal, and for bridge rectifier, the PIV equal to only Vp. So that's all for today. In my next video, I'll be discussing about the bipolar junction transistor, that is BJT. So if you like my video, then please like and subscribe my channel. If you have any questions, please drop it into my comment box. So thank you and goodbye. Stay safe.